What's up guys, welcome back to my new video. So in this video I'm going to talk about and most important data structure, the expression tree. So in further I'm going to talk about what is an expression, what are operands, what are operators, and what is an expression tree and sort of stuff. So let's begin. So an expression tree is a type of a binary tree that used to represent arithmetic expressions in a structured and hierarchical form. So the main purpose of an expression tree is to help computers to evaluate expressions correctly and maintain in the order of the operations and operator precedence. Okay, so operands and operators. So what is an operator? So in simple terms, they are the arithmetic signs that we use to solve particular equations. As you all know, they are just the plus, minus, multiplication and division signs. So, and those are represented by internal nodes, while operands such as numbers, constants, or variables are represented by leaf nodes. So each operator node has two children which represent the left and right operator expressions. So every operator connects two operands or expressions. Okay, so what is an expression? So an expression is a composed of constants, variables, and operators, which are arranged in a specific formats which are arranged in a specific rules, something like that. So an expression tree is a representation of expression in the form of a tree, like a data structure. So this is a special kind of a tree, not like a normal tree. The leaves are operands which act as an external nodes, and the operators would be assigned in internal nodes. Okay, so right now I'm going to talk about how to construct an expression tree. So right here we have two mathematical expressions. So these are some of basic mathematical expressions, and when we constructing an expression tree, we use expressions like these. So when we are constructing an expression tree, we have to do it according to two things, which means we have to concern about the precedence and the associativity. So according to these, we have to construct the expression tree. Okay, so as you can see, here we have the precedence chart. We have the brackets, and then we have the powers, then the division, and then the multiply, then the addition and the subtraction, and also we have the associated right here. So when it comes to the associativity, we have to concern about the precedence, like what part will execute first, like what part will execute secondly, what part will execute lastly. So for that we use the associativity, like when we have like long some long expression with having some some same precedence signs, then we have to look for the associativity to understand what part will execute first. So that is where the associativity comes in. So when we are constructing an expression tree, the leaves correspond to the operands, which means the operands act as external nodes, and also the operators assigned as internal nodes. Okay, so right here we have some steps to construct an expression tree. So those are the things that we follow when we are constructing an expression tree. So first of all, we have to find the lowest precedence operator. So which means according to this precedence chart, we have to find the lowest precedence operator, and then we have to make it the root, which means the lowest precedence operator becomes the root of the tree. So then after, the expression split into two parts. When we have found the root, then the expression will split into two parts, like left and right. So, and those are the steps that we have to follow when we are constructing an expression tree. So likewise, we have to follow the same rules again and again until we done the expression tree. So for example, we got the first one right here, a plus b multiplied by c. So right now, when we do this, first we have to concern about the precedence. So as you can see, we have the brackets right here and the plus and the multiply. So those signs. So we have to look at the precedence, like which one has the lowest precedence. So right here, the brackets will execute it first, and then the uh, multiply will execute it. So which means uh, this is the operator that has the lowest precedence. So which means the multiply sign will become the root of our tree, and then the expression is split into two parts. The This one will be the right sub expression, and this one will be the left. So we are beginning with the left side. So therefore, we got the a plus b, then the plus will store right here, and then the a plus b. So respectively, we are going to insert these ones. Okay, so and then we have the right sub expression. So what I'm going to do is I'm going to add that into right side. So this is the expression tree of this expression. And also we are going to do this one right now. So okay, so right here, first we have to look the what has the lowest precedence. Okay, so you can see as the operators we have the multiply, addition, subtraction, and the division. So you can see as the least number of precedence, we have the plus and the minus one. So right now we have to concern about the associativity. So while we are scanning left to right as the first one, we found the plus, which means the addition will evaluate first, and then lastly the subtraction will evaluate. So which means the subtraction will be the root of our tree. So okay, so likewise, right now we have to split the our expression into two parts. So we found the root of our tree. So right now we have to split it into two parts. So what I'm going to do is I'm going to grab this one and make this as right sub expression. So we have the d divided by e. So this is a right sub expression, and as the left sub expression we have the a multiply b plus c. Likewise, we have to follow the same rules for this expression. So we have to check the what has the least precedence. So as we can see, the plus has the least number of precedence. So therefore we have to store the plus right here. Okay, okay, and then we got the a multiply b, this one, and then the c. So this is the right sub expression, and this is the left sub expression. So likewise, I'm going to add the multiply right here, and then I'm going to add the A right here, and then the B, and then the C is remain right here because we done it early. And then as finally we have the right sub expression, which is the D divided by E. So what I'm going to do is the same thing that we do right here. So what I'm going to do is I'm going to store the I'm going to store the division sign right here, and then the D and the E. Okay, so we have done two expressions. The first one is this one, and the second one is this one. So I think you all have some idea about how to construct an expression tree. So right now I'm going to talk about the basic traversal to evaluate an expression. So the traversal is the process of visiting all the nodes of the tree with certain procedures. So as you can see, we have three traversals: the in-order traversal, the pre-order, and the post-order traversal. Okay, so the in-order traversal. So the in-order traversal is also known as the infix expression. So the nodes are visited in the order of left child, root, and then the right child. So applying in-order traversal to expression, tree produces the infix expression. So right here I have an expression. So we'll see what happened after we applying the in-order traversal to this expression. Okay, so the multiplication will be the root of our tree. So we begin with the root, and then the we got the plus right here, and then the A and B, and then the C. So so in the in-order traversal, as I said earlier, the order is the left, root, and then child, which means we go left, and then root, and then right. So so we begin with here so this is the root, and we begin with here, and then we go all the way to the left. So we got the A, and then we go to the root, and then we go to the right. So the A plus B, and then there's no more left that we can go, and then we go to this side, and then we go to the root, and then the C. So this is the answer that we obtain from after we applying the in-order traversal to this expression. So likewise we are going to do the pre-order traversal. So the pre-order traversal, also known as the prefix expression. So the nodes are visited in the order root, left, and then right. So applying pre-order traversal produces the prefix expression. So we go so we go root, and then left, and then right. So I'm going to use the same expression for all of these three. Because we already done the expression tree, so I'm gonna grab that and paste it here. So the root is the multiplication sign, and we got plus right here, and then the A, and then the B, and the C is right here. So we go root, then left, and then right. So so we begin with right here. So we got the root first. So we got the root, and then we go to the left. So we got the this plus, and then we go to the right here, and then we go to the A, and then we go to the right, which is the, and then we go to the this right here, so we got the C. So this is the answer that we can obtain after the applying the pre-order traversal to the above this expression post-order traversal. So the post-order traversal, also known as the post-fixed expression, and the nodes are visited in the order left, right, and then root. So the applying post-order traversal produces the post-fixed expression. So we go left, and then right, and then root. So likewise, I'm going to use the same expression tree. You have the plus and then the A. And the C right here. And right here we go left, right, and root. So so we begin with the all the way to the right. So we got the A, and then we got the B, which is in the right, and then we got the root, which is the plus, and then we come to here, and then we got the C, and then we got the root. So this is the answer that we obtain after we applying the post-order traversal to our expression, this one. So as you can see, those are the three traversal methods that we can apply to an expression